Okay, here we go with the last page of your lecture notes for today. This is a sample test question. Um, I have 4 parallel branches. So the current's coming here. It has 4 choices. It can go to branch 1, branch 2, branch 3, or branch 4. So the first thing I would do is I would build this table, and I started with a clean one here so that you can kind of follow how I filled in the notes that you took down yesterday. So first thing I would write down what I already know, and I know this is a 2, I know this is a 4, this is an 8, and this is an 8, just taken right off of here. I also know that my total voltage was stated in the question as a 16-volt battery. Okay? Then the first thing, just like in the series circuit, the first thing you need to start with is your total resistance. So I don't have a pair, I don't have an identical pair, so I can't use that rule. I don't have a group of 2, so I can just do product over sum. I have to use the reciprocal rule here. So I'm going to take 1 over RT equals 1 over 2 plus 1 over 4 plus 1 over 8 plus 1 over 8. Okay, just 1 over each of these numbers. I'm going to get a common denominator. I'm going to choose 8. So that makes this 4/8. That makes this 2/8. Multiplying both sides but top but bottom by 2. This stays 1/8. And that's 1/8. So you add the numerators, 4, 6, 7, 8. I get 8/8. Now 8/8 is 1, but make sure that you are in a habit of flipping it, even though 8 over 8 is still going to be 8 over 8, and it's still going to be 1. But just to get in a habit of making sure that this is 1 over RT. So this is still 8 over 8, which means we have 1 ohm of resistance. Okay? So then we go right across our table to our total current. And remember, total current is total voltage divided by total resistance, Ohm's law. 16-volt battery was stated. 1 ohm of resistance was calculated. So I have 16 amps of current. Okay? Now I have 8 other items to fill in my table. And just like in last example, there really are 4 things in this table that I really shouldn't have to show any work. Can you think of which 4 really doesn't require any work to do? It's the thing that stays the same in a parallel circuit, and that's the voltage. So this gets 16, 16, 16, 16, and you could just make a little bracket. You would make a little bracket and you would just write parallel. That's what I would expect the students to do on a test, showing their work and problem solving. We may not do that in this format, but these don't really require any work because it's a characteristic of a parallel circuit that all of the voltages would be equal to the voltage provided in 16 volts. And now all we simply do is we find out how much current we have in each of the branches. Well, just like we use V over R for total, we're going to use V1 over R1 for the current in branch 1. Well, we know each of these. Let me just do this. We know this is 16 volts. We know this is 16 volts, 16 volts, 16 volts, right? It's a parallel circuit. So we're going to take 16 divided by 2 is 8 amps. We're going to take 16 divided by 4 is 4 amps. We're going to take 16 divided by 8. Again, I'm just taking voltage divided by resistance is 2 amps. And again, 16 divided by 8 is 2 amps. Okay? If you remember in your notes for total current, does each of your branch currents, do they add up to equal 16? Does 2 plus 2 plus 4 plus 8, does it add up to equal 16? And it does. So we must have done it correctly. Okay? So that's how you work out a parallel circuit, finding the currents at any point, finding the voltages at any point, finding the total resistance. That's how you do it. Now, one quick thing I want to show you. Some of you are getting this really easily, and here's a little shortcut that you could do for resistance. If I just had two 8-ohm resistors, forget about these top two. If I just had these two 8s, what would these two be equivalent to? Well, it'd be a 4, right? Because they're two identical resistors and you just simply cut them in half. Okay, so now just pretend I have a 4 and a 4. What would those two 4s be equivalent to? That would be equivalent to a 2. Well, now I have a 2 and a 2. What would those be equivalent to? And that would be equivalent to a 1, and that's what our answer was. Okay, so in your head, as you get more and more experience and practice in doing some of these bigger parallel circuits, and I purposely chose these values to show you that simplicity of it, how you can simplify it. But and you don't have to do that. It's just the more comfortable you get with doing parallel circuits and things like that, you'll be able to pick up on some of those shortcuts and save yourself a little bit of time. So hope that's going well, and I will see you on Monday. Hopefully you have a good weekend. You have 4 days off. No, I'll see you on Tuesday. Have 4 days off. Please take a little short 30-second video, 20-second video of yourself wearing your apparel that would indicate what you're doing next year. I would love to see it, and I'm sure you'd all love to see each other's stuff too. So stay connected. Take care.